So what is it that makes you reach for that second piece of cake when you're already full? Or, what keeps you scrolling on your phone when you're not even interested anymore? Well, today we are going to dive deep into the science of pleasure and craving and get to the bottom of why our brains sometimes make us want things we don't even really enjoy. Let's get into it.
I mean, we've all been there, right? You get this intense craving for one more cookie, or you just can't stop scrolling. But then when you actually do it, the feeling is kind of hollow. It's not satisfying. Now, this isn't some failure of willpower. It's actually a fascinating quirk of how our brains are wired.
And the whole secret, the answer to this puzzle, lies in a really important distinction the brain makes. The difference between wanting something and liking it. See, wanting is the drive to get it. Neuroscientists call that incentive motivation. But liking is the actual pleasure you get from it. You'd think they're two sides of the same coin, but it turns out, in the brain, they are run by totally separate systems.
Okay, so to really wrap our heads around this, we first need to understand the basic nuts and bolts of the reward experience. How exactly does our brain decide what feels good, what's worth going after, and what we should do again? Let's just break it down nice and simple. Liking is that pure, in-the-moment pleasure. It's the delicious taste of chocolate, the warmth of the sun on your skin. It's the reward itself. Wanting, on the other hand, is the craving that comes before you get the reward. It's that powerful, motivating urge that makes you get off the couch and go find the chocolate in the first place.
All right, buckle up, because now we're going to take a quick tour of the key brain regions that make up this whole reward system. Think of it as meeting the management team that's in charge of all your pleasures and cravings. Our first stop is a little place called the ventral tegmental area, or VTA for short. You could pretty much think of this as the brain's motivation engine. It's this tiny spot deep in your brain that's constantly scanning your world, and when it sees something it thinks is important, it produces dopamine to flag it, to say, hey, pay attention to this.
So that dopamine signal from the VTA has to go somewhere, right? Well, it gets sent straight to our next stop, the nucleus accumbens. This is the action hub. It takes that, hey, this is important signal and turns it into that go get it feeling. It's what transforms the want into the do.
And our final stop on the tour is the big boss, the prefrontal cortex, or PFC. This is your brain's CEO. It's the part that's supposed to handle the long-term planning, the decision-making, and crucially, impulse control. It's the voice in your head that steps in and asks, is this really a good idea right now? It's the brakes.
So if we put it all together, the whole process looks something like this. First, a cue in your environment, say the smell of cookies, grabs your attention. Your VTA fires off dopamine signaling cookies are important. Then, your nucleus accumbens gets you moving towards the kitchen. And finally, your prefrontal cortex is supposed to step in and say, wait, didn't we just eat dinner? It's a really delicate balance between these systems.
Okay, so we've met the key players in the brain, but how do they actually talk to each other? Well, they use these chemical messengers called neurotransmitters. And understanding these chemicals is the key to busting one of the biggest myths out there about pleasure.
I am almost certain you've heard dopamine called the pleasure chemical. It's everywhere. But here's the thing. Modern neuroscience shows us that's not quite right. It's a huge oversimplification. Dopamine is much, much more about motivation. It's the chemical of wanting, of seeking, of craving. It teaches your brain what to go after, but it's not the feeling of pleasure itself.
Yeah, it's really more like a team of specialists. Dopamine is the go-getter. It drives the wanting. The actual feeling of pure pleasure, the liking, is handled mainly by the brain's own internal opioid system. And then there's serotonin, which is kind of like the teacher. It helps us learn from negative experiences and know when to hit the brakes. And this isn't just a nice idea, the data really backs this up. When scientists combine the results of tons of different studies, a really clear picture emerges. You can see it right here in this chart. Serotonin's role in helping us learn to avoid bad things is just as powerful, if not a little bit more powerful, than dopamine's role in getting us to chase good things. It's really a case of different chemicals for different jobs.
So, this reward system is brilliant, right? It's essential for helping us survive and thrive. But what happens when that system gets hijacked? What happens when a helpful path for pleasure-seeking turns into a deep, inescapable rut?
It's a slow burn. It doesn't just happen overnight. It starts with just seeking something out. It feels good, so that reinforces the behavior. Then maybe we start doing it more or more intensely. That's escalation. All the while, our brain is physically changing. It's rewiring itself in a process called neuroadaptation.
and it continues until one day what started as a choice doesn't feel like a choice at all anymore. It's become a compulsion.
So what is actually happening in the brain during this process? Well, the leading theory is called incentive sensitization, and it's a fascinating idea. It basically says that with repeated intense rewards, the dopamine-driven wanting system goes into overdrive. It becomes hypersensitive to anything related to that reward. But, and this is the critical part, the opioid-driven liking system doesn't. The result is this tragic disconnect where you crave something more and more, but you enjoy it less and less.
And we can actually see these changes in brain scans. I mean, massive studies with thousands of people have found consistent physical differences in the brains of people with addiction. But here's the really important part. These changes are tiny. I mean, statistically, the effect size is only about 0.15. To put that in perspective, an effect size of 0.2 is considered small. So the brain changes are real, they are reliable, but they're just one small piece of a much, much bigger puzzle.
Now, I know this can all sound a little bit grim, but here's the good news. The science doesn't just show us the problem, it also points toward the solution. So for this final part, let's talk about how we can restore balance to this system by focusing on the part of the brain that's supposed to be in charge.
See, the most effective strategies aren't about just gritting your teeth and using sheer willpower to fight off an urge. That almost never works in the long run. The real key is to support and strengthen your prefrontal cortex, your brain's CEO. The goal is to rebuild its ability to have that top-down control, to better manage those powerful signals that are screaming up from the wanting system.
And you can see this exact strategy at work in the most successful modern treatments. Cognitive behavioral therapy, for example, is basically like a workout for your prefrontal cortex. It builds those cognitive control muscles. Other approaches, like contingency management, work by changing the rewards in your environment. And there are even new technologies that can directly stimulate the PFC to help it get back online and do its job.
So what does this mean for us in our everyday lives? Well, the evidence points to a few really powerful things we can all do. Prioritizing sleep and managing stress are absolutely crucial. Being tired or stressed is like kryptonite for your prefrontal cortex. It also means being smart about your environment, managing the cues and triggers around you. And finally, it means actively building new, healthier ways to get that feeling of reward.
So the next time you feel that powerful craving, remember what's really going on under the hood. Remember the difference between wanting and liking. It's not a moral failing or a lack of willpower, it's a battle for balance inside your brain. So knowing all this, the question really becomes, what are you going to do to strengthen and protect your brain's CEO?